Welding 101, Metal Welding Techniques, Fusion, Pressure, Brazing. Metal welding is the process of joining metals by either melting them or pressing them together to create a strong, lasting bond. Depending on how the metals are joined, welding falls into three main categories: fusion, pressure, and brazing welding. In this video, you'll learn all about these three welding types and their common techniques, so you'll know exactly which one to pick for your next project. The first category you should know is fusion welding. It mainly works by heating two metal parts to a high temperature until they melt and join together. There are three common fusion welding techniques: arc welding, gas welding, and laser welding. Let's take a closer look at each of them one by one. Arc welding. Arc welding is all about using electricity to crank up enough heat to melt metal. The workpiece acts as one electrode, the welding rod as the other. Bring them close, and zap. An electric arc forms. That arc's heat melts both the rod and the metal, and once it cools, you've got a solid, durable weld. There are many types of arc welding, with the most common being MIG welding, TIG welding, plasma welding, and stick welding. It's a favorite for a reason. It's cost-effective thanks to affordable equipment, portable since it doesn't require shielding gas, and capable of producing tough joints for structural applications. But it's not perfect. It can waste more material than other welding methods, which sometimes bumps up costs. And it's not beginner-friendly. You'll need skill and practice to get it right. Next, gas welding. Gas welding uses a flame produced by burning a mix of fuel gas, like acetylene, hydrogen, or liquefied petroleum gas, and an oxidizing gas, usually oxygen, to heat and fuse metal parts. Sometimes, a filler rod is added to strengthen the joint. It's a solid choice for many jobs thanks to its simple and low-cost setup. Gas welding is versatile enough to handle cast iron and certain non-ferrous metals, and because it doesn't require electricity, it's especially practical for fieldwork or locations without a power source. But it's not without downsides. Gas welding has relatively low productivity. The flame temperature is lower, and heating is slower compared to arc welding. The wide heat spread can cause significant distortion and a large heat-affected zone. The molten metal also has less protection during the process, making weld quality harder to guarantee. And automation? Not so easy to achieve. Laser welding. Laser welding uses a focused laser beam, essentially a highly concentrated artificial light source, to melt and fuse metals together. By concentrating high energy into a tiny spot, it produces narrow welds with minimal heat-affected zones, helping to reduce thermal distortion. This makes it especially well-suited for thin sheet metal. It's a precision process, fast, accurate, and capable of creating strong, clean welds with minimal spatter. The results are often so neat that little to no post-weld finishing is needed. It's also highly automation-friendly, making it a popular choice in industries like automotive and electronics manufacturing. However, it does have its limitations. Laser welding can't handle gaps well. Just 0.1 millimeters of separation can cause incomplete fusion or weld failure. It's not ideal for thicker materials. Move to the pressure welding category. It is a welding method that joins two metal parts by pressing them together so their atoms bond while still solid. It can happen with some heat, or sometimes just cold pressure does the job. In this video, we'll focus on three main types of pressure welding: resistance welding, friction welding, and ultrasonic welding. Resistance welding. It joins metal parts by pressing them between two electrodes and running an electric current through. The resistance heats the metal, melting or softening it so the pieces fuse under pressure. Common types are spot welding, seam welding, projection welding, and butt welding. It's fast and efficient, great for thin materials, and creates strong, clean welds. No filler or shielding gas is needed, which cuts costs. On the downside, the machines are complex and expensive. Because the process happens quickly, quality consistency can be challenging. Friction welding. It works by rubbing two metal parts together to generate heat. Under pressure, this heat softens the metals and causes plastic deformation, which bonds the parts firmly. It's popular because it's fast, efficient, and doesn't require any extra filler. And it produces strong, stable, and super precise. Plus, it's great for joining different metals, like carbon steel to stainless steel, copper to aluminum, or even steel to zirconium. But here's the catch. Friction welding works best with certain shapes. Non-round parts can be tricky. There's also a size limit, usually around 20,000 millimeters, depending on the machine's motor power. And since the equipment is pricey, friction welding really shines in big production runs. Ultrasonic welding. It uses high-frequency mechanical vibrations, above 16 kilohertz, to join similar or different metals. It comes with some great advantages. It can join dissimilar metals like copper, silver, aluminum, and nickel, even in the form of thin wires or sheets. It can be used for both spot welding and continuous welding. The process is incredibly fast, producing strong, fatigue-resistant joints with excellent stability. There's no need for heat treatment afterward, and the welds come out clean. But there are limits. It works best on parts with a certain thickness and size. Too thick or too large, and the energy can't travel through, resulting in weak welds. Material-wise, it's mainly suited for thermoplastics and some metals like aluminum, copper, and thin stainless steel, but not for thick metals or high melting point metals like titanium or thick steel plates. And the cost is high. Both the ultrasonic welding machines and the custom tooling can be expensive. Now, let's look at another major welding category: brazing. Brazing joins metals by using a filler metal with a melting point lower than the base materials. The base metals don't melt. Instead, they're heated just enough for the molten filler to flow and bond the joint. We usually divide it by temperature. Under 450 degrees Celsius, it's soft soldering, using low melting fillers like tin lead or lead-free tin alloys. Above 450 degrees Celsius, it's hard brazing, using fillers like silver-based or copper-based alloys. Brazing has some big advantages. The base metals stay solid, so there's minimal distortion, perfect for precision parts. It works with dissimilar metals, like steel to copper or copper to aluminum. The joints are neat, accurate, and often need no extra finishing. Excellent sealing ability, ideal for refrigeration, vacuum devices, and hydraulic systems. But there are trade-offs. Brazed joints are generally weaker than the base metal, so they're not for heavy load structures. The surfaces must be very clean. Any oxide or oil will weaken the joint. Now we've covered the three main welding categories: fusion welding, pressure welding, and brazing, along with their common techniques. Let's take a quick look at how they compare. If you're not sure which welding technique fits your metal project best, our expert engineering team at RapidDirect is here to help you make the smart choice. Don't forget to like, subscribe, and stay tuned for more manufacturing tips and insights.